Thousands of years ago, roots emerged from a new seed of thought as humans began to question, observe, react to, and manipulate the world around us. These roots would one day grow into the tree of knowledge. And when we picture this tree, we might picture something very much like this, with a lush canopy, countless branches, a sturdy foundation that seems as indestructible as it is inevitable. Unfortunately, however, this is not what the tree currently looks like. Disease has crept under the bark of this tree and is rotting it from the inside out. In fact, already entire branches of knowledge have fallen from the tree and turned to dust. The situation is so bad that it is not completely absurd to suggest that this entire tree very soon will disappear entirely. In order to ensure that our society is informed by knowledge and truth for generations to come, we need to build a new tree of knowledge, a tree that is resistant to the diseases we know already exist and that can adapt to the diseases we can't even imagine yet. In order to explore what this new tree might look like, what we need in order to build it, and ultimately how we can tap into the limitless power of the public to make this new tree of knowledge, it is important we first look back and figure out how we got into this position in the first place. In order to do this, I'm going to first take the perspective of a company I work with called DSci Labs, and what we're building to develop a new infrastructure for a new tree of knowledge. I will then shift to the perspective of the Science Commons Initiative, which is a nonprofit organization working to rebuild the bridge of trust between the public and science. Then I will shift to the perspective of an open economic network called Gridcoin, which was developed in 2013. So the roots are thousands of years old, but the tree itself did not emerge until just several hundred years ago, when humans wrote down a process through which we could pose a question, develop an experiment, and perform that experiment and come to a conclusion. And through this process, we could perform the same experiment and reach the same conclusion again and again. And when we can do that, when we do the same methodology and come to the same outcome time and time again, we can say we have come to the best replicated truth of a truth that might evolve as our capabilities evolve, but given our context, the reality around us, we can say that it is something that is true. And it just so happens that the tree is nurtured. The tree of knowledge is nurtured by these replicated truths, truths that we can say with certainty are the best we can come up with because we've replicated them. But the people who created this process, the people who first wrote it down, did not write it down because they were nurturing a tree. They didn't even know a tree existed at the time. They wrote it down because they were tapping into what Eric Schultes calls the sixth sense of humanity, a collaborative sense of discovery, a sense very much like our physical senses that enables us to see the world, to understand what reality is, and then react based on that observation to make decisions, to take actions that are more likely to benefit us than to harm us. And the early practitioners engaged in this process, engaged in this sixth sense of discovery in an incredibly hostile environment. They were putting up with alchemy, witchcraft, doctrine, authorities who would rather not accept these replicated truths, who would reject this sixth sense of humanity, for fear that it would deny the wisdom on which their power rests. But still, these people, these early practitioners, nurtured the tree of knowledge till it became strong enough for them to plant it into the earth. And when they did this, more practitioners, natural philosophers, came to gather around the tree to participate in this new sixth sense, to enjoy what this collaborative sense of discovery gives you as a human. And in doing so, they added their own replicated truths, the best truths of the time, to the tree, and the tree grew new branches. Chemistry, geology, evolution, physics. But still, it was not inevitable that this tree would survive. It was a very hostile environment, so it needed to be protected from those who would add things that were not replicated, that were not true. But they continued to nurture it until eventually it was strong enough that they could present to the public. And so that's what they did. These scientists, now with a name of their own, said to the public, here's the tree of knowledge. It is filled with truths that I can prove to you again and again. And these truths will one day bear fruit, and we will use these fruits to create technologies that will improve our standard of living, that will make life easier for us. And these truths will inform our policies and our politics, and we will make society more equitable and lessen the suffering in the world. And the public fell in love with science. And societies formed around science to protect the tree of knowledge from those who would add unreplicated truths, things that could not be proven to be true, and to nurture it with things that were true, that could be replicated again and again, because that's what the tree thrives on. And the society succeeded until the tree grew to a rich canopy of knowledge with countless branches and sub-branches, biology, microbiology, virology, genomics. And researchers from all around the world, scientists came to learn from the tree and to add to it and to participate in this sixth sense of discovery, the humanity's collaborative sense, and add their best truths, their replicated truths to the tree to help it grow. And the tree did bear fruit, and we used those fruit to create technologies that gave us everything in this room. The modern world exists because of this tree of knowledge. And we used these fruit to inform our politics, and we created new political systems and new economic systems. And indeed, despite our ongoing struggles, society improved because of this tree of knowledge of replicable truths. And perhaps it was because there was no tree before. This was the first tree of knowledge. There was no other tree to learn from. Or perhaps it was because the tree seemed so strong, so sturdy, that nothing would be capable of shaking its foundation. Perhaps it's simply because nothing is inevitable and we were taking the tree for granted. But no one imagined that anyone would see this tree as an object from which they could benefit, an object of wealth and power. But they did. And these people, these new organizations, crept around the tree, and in doing so, pushed scientists further away from it, to the point that they became the sole caregivers of the tree. They decided what truths would be fed to this tree to nurture it and to grow. And they did not care about getting good replicated truths. They cared about getting sensational headlines and novel discoveries. And eventually, they created an industrialized system around this tree of knowledge. And scientists, because all they really want to do is interact with that sixth sense of discovery, that human's collaborative sense, would play these games that this industrialized system created, this system that gated the fruit off with paywalls so that anyone who wanted to access this knowledge had to pay, even if they were the ones who created the knowledge in the first place. They siloed the branches, even the entire tree off, to create these games that scientists had to play to add truth to the tree. And really, just because this is what researchers want to do, they want to interact with this sixth sense and nurture this tree as best they can, they would play these games. And they ended up stopping the replication. They ended up searching for novel discoveries. And the fact of the matter is, novel discoveries are incredibly rare. So when you're forced to produce a novel discovery in order to participate, in order to engage with this sense that you've become so attuned to, that's what you're going to do. You're going to create a novel discovery. You're going to stop your replication. You're going to stop doing anything that ties you to that process. You're going to stop taking risks and looking for following your passion down a field that might produce a null or negative result. You're going to define your entire career path based on whether or not you can produce a novel discovery. So these new caregivers did not care. They would take these unreplicated truths and they would feed them to the tree because it gave them headlines. It gave them the attention of the public. And so that's what was fed to the tree. And the tree began to rot, and it continues to wither to this day as these caregivers dig their heels into the roots of the tree and cement their position as the only ones who really know what truth is. So this is an attempt at a fun story, but really it's just describing the replication crisis. And there's a lot of numbers and stats up here. You can read them if you want. That the replication crisis can really be summed up in a simple example having to do with Alzheimer's. Several decades ago, there was foundational research put into Alzheimer's. What are the mechanisms that caused it, and how can we build treatments and preventative measures to stop this horrible disease? That knowledge, that fundamental knowledge that was novel and groundbreaking at the time was added to the tree of knowledge without being replicated first. And we spent several decades, tens of billions of dollars, and the countless hours of some of the greatest minds in this field spent their entire careers building on this foundational knowledge that was never replicated. And it turns out that this knowledge was just fake. So all that time, all that money was completely wasted. That entire branch just fell to the ground and turned to dust. So this happens more often than we'd like to admit. It's more often a outcome of the system, of this industrialized system, where there's just no incentive to replicate, so things aren't replicated. But there are malicious examples, and they are certainly sensational, so let's use them just like they do. There is also another disease that has crept into this tree. It's called link rot. Link rot is when you try to find a piece of knowledge, a piece of research, and instead of getting to that research, when you click a link, you're taken to 404, page not found. That's fine if you're trying to find your GeoCities site for middle school. That's not all right if you're trying to find a foundational piece of knowledge from which you can build a new medicine or a new rocket fuel. It is absolutely insane that that's the situation we live in, where we can't find knowledge that was discovered decades ago. I've already talked a little bit about the perverse incentive structure of this industrial tree of knowledge, so we'll move on quickly from that. But the outcome of all these problems, and so many more that I'm not highlighting, is that the tree is rotting in very public view. Everyone can see that the tree is not safe to sit under, it's not safe to climb, the fruit are not safe to eat. And because this tree is what defines our reality, what gives us an understanding of the world we live in, and because humans need something like that, we need something to tell us about the world around us. And if we can't trust this tree anymore, we're going to find something else. And that new thing is not going to be rooted in knowledge. It's not going to be rooted in truth. It's going to be rooted, again, in witchcraft, alchemy, doctrine, and conspiracy. That's not only a shame, that is incredibly dangerous. So we need a new tree of knowledge, and this new tree of knowledge is going to need some new infrastructures. It's going to need a new data infrastructure, which many of us know about here in this room. This data infrastructure is going to need to be capable of storing the vast volumes of data that we create. We're going to need to be able to surface any content I call at any time, 100% of the time. The new data infrastructure is going to need to be able to run compute over this data. It's going to need to be able to interface with both humans and machines because AI is already here, and it's going to be beautiful if you think about it. Think about the computer from the enterprise and not the robots that are going to kill us all. We're also going to need a new social infrastructure, a social infrastructure that elevates research and researchers to the status that they deserve. This entire room, modern world, is created by researchers. They are the most valuable creators in our society. They pose questions, give us methodologies, that give us answers, that let us shape the world around us. They are the heroes of the modern world, and they need to be honored as such. So we need to create a social infrastructure that pays them more than a livable wage, which is barely what they get paid right now. We need a social infrastructure that incentivizes them to follow that sixth sense of discovery, to follow their passion, whether or not it leads to a novel discovery or a null result. We need to incentivize them to replicate and do the scientific process the way it was first designed. We're also going to need a new quality infrastructure. We're going to need a new way to define what good, impactful science is, because citations, as Gustav Nielsen's here, are a poor measure of impact. They measure something, perhaps. So maybe they're an aspect of this new quality infrastructure, but they certainly shouldn't be the only one. This new infrastructure needs to align with the incentives that we build in our social infrastructure that let scientists follow their passion and build on the scientific process and the knowledge that came before them, lets them collaborate with each other and not beat each other's throats. We need a new communications infrastructure that destroys publish or perish. In fact, we probably need a communications infrastructure that lets anyone publish anything at any time for free. So we need a new tree of knowledge, but it's not as though we're starting over. We have the lessons we have learned, we have the history of the current tree of knowledge, we have the technologies that the current tree of knowledge has given us. We have the internet, the technologies developed over the past 14 years, we have the technologies we're all developing here in this room. So we can take these lessons and combine them with the technologies, and what we can do is create a digital tree of knowledge. And the first thing we're going to need to do in order to create a digital tree of knowledge is store all knowledge on a permissionless, decentralized open ledger, accessible to all, dependent on code, and forkable by anyone. So that if anyone tries to silo the tree, we can fork it and make it open again. We're going to need to create truly decentralized permanent identifiers so that if I look for a piece of research, a piece of knowledge, you better damn well believe I'm going to find it 100% of the time. We're going to need to tie all components of research to that parent research because research is so much more than a PDF. It's more than a manuscript. It's data and code and so much more. And each of those things need to be independently citable, but also tied to that parent object. Everything is going to be a knowledge graph. And we call these things rich, interoperable research objects. We're going to need to create gateways into this ledger that surfaces content in a meaningful way, because when we lock the gates open, when we let anyone publish anything at any time, everyone is going to publish everything all the time, and we're going to need to be able to view this stuff in a meaningful way. So a gateway, you can think of Harvard, MIT, BU, they're all going to have their own gateway, and they might surface content that is funded and produced at their institution. Or I can create my own gateway that produces content that I like, and it's going to be the best gateway you've ever seen. Or, Nature can produce their own gateway that surfaces content that fulfills the requirements and their standards, and it will be an honor for researchers to be surfaced in the Nature gateway. But the difference here is that Nature is not being the people who are saying these publishers or these researchers can publish. They're drawing from the same pool of publication as everyone else. This is the new role for publishers. They are curators, not caregivers. And people will pay to access that gateway because it is a valuable service. Curation is not easy. So to replace these publishers and these other organizations as caregivers of the tree of knowledge, we need to invite scientists back to the tree so that they are the ones nurturing the tree. They are the only cohort of humans who have been able to prove that they are capable of nurturing a tree of knowledge in a hostile environment. If we do all these things, we will have the first step in creating a digital tree of knowledge. We will have an open repository of knowledge. Next, we will need to measure all interactions within and with each research object and its components. Every time it's cited, reproduced, replicated, built on, refuted. Imagine being able to look at the theory of general relativity and seeing everything that came off of it in a knowledge graph and how impactful each thing that came off of the theory was to the thing that came next, all the way down to GPS and cell phones, the things we use today. Once we can measure everything, we need to create the tools for anyone to create their own impact algorithm. Because what makes good physics research is going to be different than what makes good psychology research. And the impact algorithm used by a funder looking for early stage research is going to be very different than an impact algorithm used by Nature magazine to surface their own content. And once we have these open impact algorithms, users are going to be able to toggle among them at will at any time to filter the open repository of knowledge in any way they want, and we'll have open impact algorithms. Next, we will need to create tools for people, societies, institutions, anyone to stamp a research or researcher with an attestation. And the attestations are the solution to the replication crisis, or at least one aspect to it. You can think of them as such. If I'm a trusted institution that is good at saying what has been replicated, I can scan the ledger, this open repository of knowledge, and find replicated research and stamp it with my attestation. Say this has been replicated 5 times, 10 times, 50 times, 5,000 times. And now a user can go through and filter the ledger based on those attestations, mine and so many others. A funder can use those attestations to find the research they're looking for, making sure that something's replicated before they build an entire branch of knowledge on it. Remember, tens of billions of dollars were wasted on this Alzheimer's research simply because it was not replicated first. So when we have these attestations that anyone can stamp on research, we will have open curation and funding networks. And what's more with these, the impact algorithms can also integrate attestations into how they define what good research is. And finally, we will need to build crypto-economic models that incentivize the critical, non-translatable, the foundational aspects of the scientific process, the replication, the peer review, the attestations, all those things. We need to use cryptoeconomics because it is stable, it is proven, and it is tied to another critical aspect of society. Let's call it the tree of value for now. And it's a little different than hypersearch and retroactive funding because it generates a currency from the beginning. So we will also need to build pathways for the public to engage and contribute and learn from this tree of knowledge, because while the scientists are the caregivers to the tree, the public is certainly the primary stakeholder of the system of science. They need to live with the outcomes of science regardless of anything. We have no choice in it, we have to live with it. And if we do all of this transparently and through open source software, we will end up with a robust digital tree of knowledge accessible to both humans and machines. And what's even more interesting is because all of this is open source software, because anyone can create attestations, because anyone can create and use impact algorithms, and it's all built on an open repository of knowledge, and anyone can create a gateway, we will probably end up with more than one tree growing side by side. And each tree will be a little different than the tree next to it. We will end up with a forest of knowledge. And a forest is a much more robust organism than a tree. It is able to adapt to the challenges that are coming, and over time the trees will evolve to survive for generations. So DSci Labs is working to build the infrastructure of this new tree of knowledge, this new system that will hopefully help society stay informed by knowledge and truths. The first thing we've built is called DSci Nodes. Nodes is the application, the platform by which a researcher can publish a rich, interoperable research object. They can tie all their components of research to a parent manuscript and publish it in one place on an open repository of knowledge. Once it's published, it gets a PID, all of its components get a PID, and it's all tied together in one place. In fact, dpid.org was just released last week. I was in a desert, so I haven't had a chance to look at it myself, so please take a look. Let me know if it looks good, what we can do to make it better. But Research Nodes is working to elevate research to the level that it deserves. And one of the easiest things, one of the first things we've done is create cover art for all nodes that are published. So here's research on capybaras, their skin health in hot springs. And I, as a member of the public, definitely want to read more about this because that capybara looks incredibly cute. So I'm going to turn the page. But when I turn the page, there's going to be jargon and charts and math that I'm just simply not going to understand. That's okay. And this is a different piece of research just to showcase a timeline here in a minute. But I'm going to see annotations when I open up. Annotations that may have been created by a science communicator that explained this research in simple language that I understand. And this science communicator might be completely unrelated to the PI. But they were inspired by this research. They want to communicate it to other people. So they create these annotations. They submit a merge request to the PI. The PI maybe accepts that merge request. And now that science communicator is part of this research object. They have added to the tree of knowledge themselves. And now they can take that experience and go and build a career out of it. And this timeline on the right is very important because knowledge is a process, not a static outcome. And we need to be able to always look back at the first iteration and make sure we haven't lost any nuggets of knowledge along the way. And also, our hope is that by developing this timeline and supporting provenance in research, we can incentivize researchers to once again publish as they produce and collaborate early in the process, so that we're asking questions early in the methodology, in the development of the methodology. We're collaborating very early, and we're creating a more efficient system of discovery. We're accelerating the pace of knowledge creation. Here are all the components you can upload through DSci nodes. I will move quickly past that, but here's what it looks like when you upload code through nodes. And this code can be reproduced on the user's side in the application. The user can show themselves, see for themselves that all the charts and the graphs in the research, in the manuscript, are accurate. And what's more, the user can manipulate this code on their local environment. And maybe they find a way to make things more efficient. Maybe they find a novel discovery through the analysis. Maybe they just replicate something. But whatever they do with it, they can submit a merge request to that PI, and that PI can accept that merge request if they want. And once they do accept that merge request, this researcher, this user, is now part of this research object. They have now become a researcher. It didn't matter their socioeconomic status. It didn't matter their nationality. It didn't even matter if they had access to a university. All that mattered is they wanted to engage with that sixth sense of humanity, the collaborative sense of discovery, and they did through nodes. This is what data looks like when you publish it on nodes. You can see each data set is individually citable. And when its data set is cited, that data set itself gets citation credit, the parent object gets citation credit, and the researcher gets citation credit. And the PI that cites it in the first place can do whatever they want with that data set in their own research. The next thing we're going to be building are gateways, these portals into this open repository of knowledge. We hope to have some pilot projects out in the coming months, definitely by DSci Boston, which will be taking place this fall here in Boston. And we are inviting scientists to the table through 3 programs. The first is called the Node Stewards Program, where scientists and science enthusiasts, the public, anyone with any background, can go out into the traditional world, find research and all the components which are spread all across the internet, collect them and publish them all as a single research node, as a rich interoperable node. This is a great program. I do recommend you get involved in any of this stuff. It's interesting. We also have the Future of Science seminar and podcast, where we invite meta-scientists to the table to talk about the current state of science, how we can make it better, and the potential future of science. In fact, all the quotes you've seen today are from the Future of Science seminar and podcast, so I know I'm going quickly. If you're not able to read the quotes, go listen to the podcast. And of course, everything we build is open source. We invite you to come build, break as best you can. It's a lot of fun. So that's what we're building at DSci Labs. It's the infrastructure for a new system of knowledge, a new tree or a forest of knowledge. And it is going to be critical to organizations like the Science Commons Initiative, which, as I said, the core mission is to rebuild that bridge of trust between science and the public. So we're asking ourselves, how can we plug in these new infrastructures that Labs is building, that all of us are building, in order to really engage the public, get them into the scientific process, and let them learn and participate and start to trust science once again. And again, in order to move forward, it's important to look back, this time with a more optimistic perspective. We're going to look back at one of the most successful distributed computing networks that's ever existed. This is SETI. I'm sure everyone knows what SETI is. If you don't, talk to me later, I'll explain it. But SETI evolved into BOINC, the Berkeley Open Infrastructure for Networked Computing, on which dozens and dozens and dozens of distributed computing projects have formed. This network, this distributed computing network, produces more processing power than we could ever use as a society. It produces everything we need, and it scales naturally. There's no need to build more processing, because it taps into the processing that we all use in our daily lives just when we're not using it. So every car, every refrigerator, every phone, all these laptops, when you're not typing, could be using we could be using that processing power for science or any of society's computational needs. And as I flip through some of the results that BOINC has come up with over the years, it's important to understand that the people who contribute their processing power, their idle processing power, to this platform do so with no expectation of return. And it actually costs them money, because we have power bills. It costs money to run a processor all the time. We're only looking to tap into that sixth sense of discovery as little as that interaction is. We're not researchers ourselves. We're just doing what we can because we want to, because it's fun. And that's how powerful this sixth sense is for a good portion of society. However, it's not for everyone. So we have to ask ourselves, BOINC currently has a fraction of percent of that 6,000 exaflops, which is a number estimated by David Anderson, who is the creator of BOINC, in 2019. So that number is probably outdated by now, and it's probably conservative when it was estimated. So if we're tapping into a fraction of a percent of that, how can we get that up to 10%, 20%, 60% of idle processing potential in the world, contributing to society's computational needs? Well, what if instead of waiting for this sixth sense to evolve, we tap into a more instinctive emotion? What if we tap into greed? And in order to make money, in order to be greedy, you have to contribute your idle processing potential to society's computational needs. So this is where Gridcoin comes in. It's a coin from 2013. It basically does just that. And it does more than that, because if we think back to the last step in building a new forest of knowledge, we're going to need a crypto economic model that incentivizes people to do that foundational work of the scientific process. And what's more foundational than to modern science than computation? You know, one day we will figure out how to do replication and peer review and all that, but mostly those things will probably require a web of trust, and web of trusts are difficult and they have to emerge over time. We have computation already. Computation is relatively easy to measure, and we can just start experimenting. So that's what we did. I also always have to show this slide because we have been around for a very long time with continuous development. It's just fun to look at from my perspective. But the thought now has to go to, where does money come from? How are we going to incentivize people with a crypto economic to model to offer their computation power to this giant distributed computer that has more power than we could ever need? Well, if we look where money currently comes from the Treasury Department, who creates treasury bonds, sells those treasury bonds to banks who pay an interest rate on that treasury bond, but they loan that money out to consumers who pay a higher interest rate back to the banks, and those consumers produce things and pay taxes back to the Treasury Department. We're made to believe that that cycle should work, but we know it doesn't work because banks gamble. We're actually going through this process right now. Maybe they put all their money into tech companies and, you know, there's a downturn in the market, so those banks go out of business. They fail. And when they fail, we need a Federal Reserve to bail them out. And what they do is they print money in exchange for treasury bonds, and those treasury bonds eventually expire, but in the meantime, they earn interest, and that interest goes back to the Treasury Department. So it's a cycle that, you know, can work for a good number of, it can go through a couple cycles before it ultimately fails, but it probably will one day just completely collapse, right? It's because it's all predicated on debt, this idea of a thing. It's not based on a commodity. It's not based, as Juan was saying, on energy or anything of actual value. And the US dollar is valuable, it's worth something, only because those people who create the debt in the first place demand this currency that they print be the thing that pays them back. So if I take a loan out in US dollars, I have to get US dollars again to pay them back. Either I have to work for it, or I have to buy US dollars. So this debt system does not make sense. So what happened a little over a decade ago is we created a new system. We first changed the consumer to the public because the public has commodities. We have things. And then we created a new treasury, and it's called Bitcoin. And that treasury takes a thing from the public, electricity, converts it to computational energy. And in return for that computational energy, the treasury disperses the Bitcoin that it mints. And that exchange produces, the treasury uses that energy to secure a public ledger, which tells us who has how much money and where it is. And in order to access that ledger and really move money across it, you need to use the money that the treasury creates. There's no debt here. There's only commodity economics. So this works. It's going to continue to work. It's a very, very good system. But we can build on it. We can experiment with it because it's open source. So that's what we did. We made our own treasury. It's called Gridcoin. We use stake. And the original coins for GRC to start this proof of stake system come from a proof of work era similar to Ethereum, just done well before Ethereum existed. In exchange for stake, the public gets GRC in return, and this process secures that same ledger, and here's essentially Bitcoin and proof of stake, right? But we have the stake system, which means that we have computation power still in the public that we can use. Let's use it for something. So instead of a Treasury Department, let's do something useful. Let's get an approved researcher, send the computation power to that approved researcher, who is approved by the public in the first place, and that approved researcher is going to keep score of who contributes how much computation, and that scoreboard is going to go to the Treasury Department, who puts it into the ledger, and then that Treasury Department will look at that ledger to determine who gets how much of the currency that the Treasury Department mints. So the Treasury Department is distributing the currency it creates to both stakers and to people who are contributing contribution cycles to approved researchers. But this cycle cannot stop here because we have another person who is creating something of value, another commodity. An approved researcher creates knowledge, and knowledge is useful. So instead of creating this invisible thing called debt, they're going to create an impactful outcome. Let's say they model the spike protein for SARS-CoV-2, which is actually what a BOINC project did. And that impactful outcome, the cycle has to continue because it can be used by people. And it's not used by banks, it's used by approved translators. And these approved translators have an incentive to produce something to sell to the public, like a vaccine. And the public doesn't get a vaccine for free, they have to buy it, but they're using the currency that they earned by starting this cycle in the first place. So they submit their electrical energy to an approved researcher, get money for that. In return, they use that money to buy a commodity, again, something useful. And the approved translator is approved by the public. This is important for reasons I won't get into right now, but there are more layers in here that we can add, and you're going to hear about these tomorrow. There's these things called benefactors, and these benefactors are approved by the public themselves, and a benefactor is someone who maybe sees a translatable object that they just need a little computation to get to, and once they get to that, they'll be able to sell it to make money. So in the beginning, they inject money into the scoreboard right at the start. That money goes to the treasury, into the ledger, and then the treasury uses that ledger to determine how much of the benefactor's money to distribute to which crunchers, whoever contributed to that project in the first place. And there's another layer, which I won't go through in its entirety, but because we have the infrastructure that DeSci Labs is building, we have PIDs and knowledge graphs. These approved translators, once they start making money, the money can be redistributed through the system to the people who produced the impactful outcome that was used in the first place, and even to the public who contributed computation to these projects that produced an impactful outcome. It's not like the approved translator doesn't make money, they still make bank, but some of it trickles back through the system. So it incentivizes the public to find the basic research that is the next theory of general relativity, because that theory created so many translatable products that if you fund with your computer that next theory of general relativity, you're going to be making passive income for the rest of your life. There's no need to do anything else. That is the incentive of the public to find good research. So this is very important. Very briefly, who gets how much compute? It's 1 over n, where n is the number of computation projects on the network. So every foundational project is guaranteed to get a share of the computation in the network, because we can't let people just buy compute, because the theory of general relativity, no one was going to pay for that. No one did pay for that. You did it because it was fun, right? So we need to make sure that everyone gets this foundational resource, computations in science. So I will end with this. This is a QR code that will take you to a tree of link trees. And on that link tree, you will see DeSci Labs, DeSci Foundation. If you click my own link tree that's linked there, you'll get to Gridcoin and the Science Commons Initiative and some more writing on DeSci. But I'll generalize this quote a little bit as you all scan the QR code and click all the links. Just like it was not inevitable that the original tree of knowledge was going to survive, that it required people in the room making sure it survived, pushing it in a certain way. And just like it was not inevitable that the internet was going to be born into, was going to form into what we have today. In fact, banks tried to buy TCP/IP at one point, but there were other people in the room making sure there were other options available. There were other conversations being had and other products being made. It is not inevitable that any of these open permissionless systems that are currently being born or being attempted to be born at this time are going to turn into something good, bad, or anything at all. So it is incredibly important that we're in the room, and if we are in there with someone else and it sounds like they're trying to maybe buy TCP/IP, or maybe they've lost sight of these open principles, the original goal in the first place, open source, open data, open science, all these things, be very cognizant of your choices and don't be afraid to leave the room and go somewhere else. We are the ones that are building this stuff, and it is critical that we build stuff that's worth building. Thank you. So.